Hi, in this video we are going to look at the March 2019 physics paper 2 9702/22. It's the CIE physics paper and question number 3. Two balls X and Y, this is X and this is Y, move along a horizontal frictionless surface as illustrated. Ball X has an initial velocity of 3 meters per second in a direction along the line AB. Okay, keep an eye on AB. Ball Y has a mass of 2.5 kg and an initial velocity of 9.6 meters per second in a direction at an angle of 60 degrees to the line AB. Okay. The two balls collide at point B, this is B, and the balls stick together and then travel along the horizontal surface in a direction at right angles to the line AB as shown in figure 3.2, as you can see here. Before anything else, I am going to call the direction along AB as X is the X direction. Okay, let's label this X direction along AB. Perpendicular to that, I'm going to label it Y. Okay, I've also shown that to you here. Okay. And before anything else, let's mark in the components of the velocity of Y. So along the X direction, we have 9.6 cos 60, and perpendicular to it, we have 9.6 sin 60. That's because this angle here is 60, so here it is 60 degrees. Okay, take note. X here, ball X, has only a component in the AB direction. Okay, there's no vertical component initially. Good. Now let's see what the question wants. By considering the components, let's move it up a little bit. By considering the components of momentum in the direction from A to B, show that ball X has a mass of 4 kg. Okay, we are going to use the idea that momentum is conserved both in the X direction and the Y direction. Okay, let me just use this. Okay, again, the principle that we are going to use, we're going to say momentum is conserved both in the X direction and the Y direction. Basically, we are using the principle of the conservation of linear momentum, except that now we're going to apply it in the X direction first, and then later on we'll apply it in the Y direction. Good. So consider this is not moments here, this is momentum here. So we're considering momentum in the X direction. So before the collision, total momentum will be, so let me write it here, sum of momentum before collision will be sum of momentum after collision. Okay, so except that, like I said earlier, we are going to consider first this idea in the X direction, and then we'll consider the same idea in the Y direction. So first let's deal with it in the X direction. Okay, that is in the direction of AB. So before collision, momentum is what? Momentum is mass times velocity, mv. Okay, so before collision, X is moving to the right with velocity 3. So I'm going to assume moving to the right as positive v. So momentum here will be 3m. And for y, the momentum will be Okay, before collision will be 2.5 times, good, minus 9.6 cos 60, because this component is acting to the left. And the good thing is, after collision, they are, remember, the two balls collide, and after collision they stick together and travel in a direction at right angles to the line AB. That's what you see here. Therefore, in the x direction there is no momentum. Yeah. So, using the principle of conservation of momentum in the x direction, momentum before collision equals momentum after collision. So we write 3m plus 2.5 times negative 9.6 cos 60. That will be equals to 0. Again, let me remind you, why is it 0? Because after collision, the two objects which coalesce, they move in a direction which is perpendicular to x. So clean this up and you'll get m equals to 4.